Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter. T minus 7 seconds.
Bill Nye the Science Guy.
Tell me. I'm Bill, and I'm 5, and we're Bill 5, the Science Guys. 5. First things first. Gotta check for clues in the problem. Figure out the topic, know where to start.
Oh, show, but speaking of topics.
Let's eat.
You're awful. Hey, Bill, you got anything to eat?
For sure, bro. Mom got me pizza. It's in the oven.
Hey.
Domino's.
Always, dude.
Favorite. Is this a clue?
Sick, bro.
It's a clue. What's it say?
Says, talks about charges and Q in the problem.
Okay, so if Q's mentioned in the problem, talking about charges, for sure electricity.
Yeah, dude, for sure.
Done.
Hey, Bill, there's a clue here.
Oh! Hey, 5, there's a clue.
Oh, sure. It's set.
I don't know, read it off.
Mentions voltage or ohms in the problem.
Okay. The thing is, though, electricity and circuits, really similar things. For the circuits ones, it's going to definitely show a picture of a circuit, though. If it doesn't, for sure electricity.
Saw, dude.
Bro, ESPN alert. He game just started.
Dude, let's go.
Okay, let's go watch
Alright.
it.
Yeah, dude.
Alright, you ready?
Yeah.
Yeah, dude, it's pretty nice inside, not gonna lie. It's
Yeah,
pretty
for
calm up
sure.
there. Oh my god. Dude, a no.
I
Yo.
think it's another clue.
True. Mentions resistivity or resistance.
Okay. Hey, gotta be cautious of the circuits problems, too.
True.
They could be the same.
Yeah, they got
Make sure there's
resistors.
not a picture of a circuit in there.
Dude, doors are so difficult. Not gonna lie.
For real, bro. You just ran right into that, bro.
Let's get this game
Literally.
going. Let's get this game going, bro.
Oh my gosh.
Oh my god.
Okay.
Alright.
Okay.
Alright.
Yep, Maddie messed up the TV.
Yup.
How are we supposed to watch the game with that piece of paper all over the TV?
Bro, that's a clue.
Is
Dude,
it
that's
really?
another clue.
No way.
Oh my god. Oh my god.
Clue number
Yo, let me see
4.
this, let me see this.
Clue number 4.
Yo, it says uses current, which is total charge over time.
Okay. Okay.
Okay.
Okay. Bro, where could clue number 5 be?
Oh, hey, Maddie, how's it going?
It's on her face.
Oh, dude. Oh my gosh. Alright, what did it say?
Oh, that's hilarious.
Potential difference and power.
Okay, so if it mentions potential difference or power,
Yeah, of course.
for sure electricity.
Yeah, and power equals IV.
Okay.
Alright, cool.
Definitely don't need that last part. That's higher laws. Okay, fine. Let's go over some laws and definitions.
Alright, Bill.
Okay. First, definition. Start off with electricity. It's the study of moving charges, such as charges flowing through a wire.
Right. We got another one. We got potential difference, which is the same thing as voltage, which is a change in potential from high to low that chargers will move with. So it starts off at the high end and it moves through to the negative end where there are 0 volts.
Okay, cut. Okay, let's talk about current. Current's the flow of electrons through a cross-section of material, such as a wire. To solve for current, simply take the total charge passing through a point divided by the time in seconds. This can be demonstrated by phi over here, below. Think of the ping pong balls as the total charge and the hoop as the point.
Resistance. That's how much an object opposes the flow of charges. The equation for it is R is equal to PL over A, where R is resistance, P is resistivity, L is length, and A is a cross-sectional area. You can think of the cross-sectional area as a pipe. When the pipe is bigger or wider, the water flows through it more easily. You can think of L for the length, that when a pipe is shorter, water also flows through it easy.
Let's talk about resistivity in the equation. This metal rod has a much lesser resistivity because it's a conductor. Electrons are going to flow much more easily through this
than this wooden bat, which has very high resistivity and is not a conductor, it's an insulator.
A major part of electricity is the force between electrons, which can be defined by K times Q1 times Q2 over R squared, where K is a constant for the force between electrons, Q1 is the charge on the first electron, Q2 is the charge on the second electron, and R is the distance between the electrons. An important fact to remember is that no matter what magnitude each charge has, they exert the same amount of force on each other, and neither exerts more force on the other.
When trying to solve a calculation problem, what you're going to want to do is try to find variables that you can find in the formulas we already know, and use the information given to find the unknown variable that we need to find.
Okay, let's talk about a conceptual problem. Two like-charged objects are separated by a distance d. The first charge is larger in magnitude than the second charge. Okay, so you know that this is talking about the force between charges. It talks about magnitude and that it's like charges. So you need to understand that like charges repel and opposite charges attract. Since these are like charges, you know that the forces between the charges are going to be opposite in direction. Also, you know that the magnitudes are going to be equal because the magnitudes between two like charged objects are always equal no matter the magnitude of each charge. Okay, now let's talk about a graphical problem. The first thing you need to understand about graphical problems is you just have to have an understanding of the formulas and how each variable relates to each other. Alright, so let's get it started. Determine the graph which correctly relates resistance and cross-sectional area. Well, we actually have a formula which relates resistance and cross-sectional area. It's defined as R equals PL over A, where A is the cross-sectional area and R is the resistance. So as seen in the formula, you clearly see that they're inversely related in a linear relationship as there's no squared variables. So you know that as cross-sectional area increases, that resistance is going to decrease. And the answer is B. Let's talk about an experimental problem. Determine the least amount of variables needed to determine the resistance of a specific copper wire. The first approach to this problem is to determine an equation that relates resistance with other variables. We know that there is an equation for this defined as resistance equals P times L over cross-sectional area. So the only thing needed to determine the resistance is the resistivity, P, the length, L, and the cross-sectional area, A. So clearly the answer is A and C, given by the answer choice E.
Thanks for watching.
And just remember, we are
Bit of the science guys.